Sorry for the break in transmission. We're starting now. So we're going to share the outline with you. Please bear with us. We will share that with you soonest. Okay, so today we're going to be looking at some of these things we already know. For those who passed through the, let me get, is this a master's class? Let me just be sure I'm in the right.
Yes, sir. We are the master's class.
Okay, so let me just be sure that let me just be sure that I'm in the right place. Okay, so today we're going to do talk about the common terms in statistics, the role of BIOD class. You'll be familiar with some of the things here. Slides are basically the same, but some things as we go along. So I'm Dr. Abiye Somiari, for those who do not know me. I'm a public health physician. Okay, so we shall look at today's topic under the following headings. Just a brief introduction to statistics. And then we'll look at the types of statistics, the role of statistics in health, types of data, sources of data, components of a datum, as well as the types of variables and the scales of measurement. So please just pay attention so that we are all on the same page. Apologies for starting late. So what is statistics? I'm sure when we think of statistics, we think numbers. We think numbers, we think calculations, we think statistical tests, we think high things. But what you should know is that there are principles that underlie people who are, gifted in all the statistical tools and softwares. But there are principles underlining statistics. So what is biostatistics? So it's more like you're applying statistical methods to health and biological sciences. So it is the application of statistical reasoning and methods to solve biological problems, medical problems, or public health problems. Just as you have, when you're doing a research, you have a problem that you want to address. Same thing with statistics. Statistics guides you towards following the numbers or the data to make meaningful conclusions out of them. That is what statistics is all about. So it is the use of the scientific use of information to describe or draw inferences about natural phenomena. So quantitative in the sense of numbers. We're thinking of numbers, we are thinking of how to use these numbers to answer, to guide us in making our decisions in health. So basically that is what it is. And then to make an inference. So from all that we have done or said or been able to calculate, what is the data saying? Is it pointing towards a solution? Is it pointing towards a problem? Is it telling us, okay, there are associations? Is it trying to explain, things? So we work with the data. Of course, we know that whatever data we collect, that is what is going to be analyzed. So the process of data collection is very important. So your validation checks should be in place. If you're using research assistants, it should be people who know what they are doing, because you don't want people to go and falsify data and be giving you conclusions that are wrong and does not speak to the issue at hand. So uses of statistical methods to collect data, so we are designing down to the way in which your study tools are designed, is quite important. And then you're designing your tools with the objectives of the study in mind, or the objectives of the research in mind, to describe the characteristics of a group through data summary and presentation. So that is in the realm of descriptive statistics. So in descriptive statistics, as we shall see down this in this lecture, we are basically involved. So that involves summary, data summarization. We want to see what is the data telling us, like what is the summary of the data really, and how it is presented such that we can make sense of it. So a layman who sees a chart or a graph can be able to say, oh, this is what is happening to the data as such. So we need descriptive statistical methods, we need inferential statistical methods. Then for the drawing of conclusions and the associations, the predictors, and all those things we find out from the data, we cannot use the descriptive statistical methods to answer those research questions. So we'll need to now use some form of inferential statistical methods to assess, draw conclusions, as to get evidence from the data. So basically, this is not exhaustive, but at least these are the basic uses. In the field of statistics, we're going to be using some terms, and it's important that we know. So the population is the entire possible units of analysis of interest. So if I'm interested in carrying out a study among undergraduates in the University of, or should I say postgraduate, since this is a postgraduate class, among all the postgraduate students of the University of Port Harcourt. So the population represents all the postgraduate students. That's the population. But because of cost, because of logistics, we may not be able to study all the postgraduate students of the university. Cost, logistics, sometimes ethical reasons, depending on the subject matter that is of interest for your research. So we take a sample out of it. And this sample is a representative sample. So as much as possible, this sample should represent the population from which it was drawn. Representative as possible. So if you have 70% of the postgraduate students of the university are males, in your sample, it should be reflected as such. Then the sample size. So knowing fully well that you need to collect a sample from the population for your research, one of the things you'll be asking yourself is, what number of the sample am I supposed to take to carry out my study? So that's where the sample size comes in. And then I think somewhere in this course of the lecture, we're going to be discussing the sample size calculation. So the sample size formula to use will depend on the objectives of your study, to depend on the outcome variable, will depend whether you are doing, whether the outcome is a means, that's whether the outcome is quantitative or categorical. It will depend on whether you are matching or not. So when we get to sample size calculation, we'll see. So if you're doing a research, okay, what number of the sample am I supposed to collect from the population? So you will now calculate your sample size, and that will now give you the number. So having calculated the sample size, you ask yourself, okay, so how am I going to select? So if I've calculated a sample size of 500, so of all the postgraduate students of the University of Port Harcourt, I want to select 500 of them. What method or how will I select these 500 from the entire postgraduate students that we have in the University of Port Harcourt? And that's where the sampling technique comes in, which is the process of selection of the sample. So we have the probability sampling methods, we have the non-probability sampling methods. So all these will depend, the type of sampling methods to use will depend on the type of study. But as much as possible, if it allows, the probability sampling methods are preferred in quantitative research, because you are giving everybody as much of an equal chance as possible to be selected in your sample. So if we were able to work with, to study the entire postgraduate students now, that's the entire population, whatever summaries we make from that data, those summaries are called parameters. So for example, if I'm able to measure the weights of the entire postgraduate students of the University of Port Harcourt, if it were possible, the mean weight will be the population parameter. But most times we work with samples. So whatever it is, let's say we have collected 500 from the population, we've sampled 500 from the population, and then we have the mean weights. That estimate from the sample is known as the sample estimate. While if we were able to calculate the mean weight for the entire postgraduate students of the University of Port Harcourt, that's the population, that summary measure is the population parameter. But sometimes we may not know what the population parameter may be. So this is where inferential statistics come in. So we are making use of the sample estimate to make inferences on what the population parameter will be. So that is important to note. So in this slide, I've said so many things. I've talked about population, I've talked about sample, I've talked about the population parameter, I've talked about the sample estimate and how the sample estimate is used to make inferences on the population parameter. In fact, that's the whole gist around inferential statistics. It may be difficult to study the entire population, so we take samples out of it, which should be as representative of the population from which it was drawn. What number now are we supposed to take? That's where the sample size calculation comes in. Having calculated the sample size, we will have a number. We'll have a number, and then out of that number, we'll now say, okay, let us now select using a sampling technique. 1 minute, please. Let me answer Professor Tobin West. Okay, so let's move on. Okay, so what the types of statistics? What are the types of statistics? So we have the descriptive statistics. So I've tried to say something about it already, but it just in this method deals with the description of the sample without drawing conclusions. So you're not trying to say, oh, this is associated with this is linked to this. You're just describing what the data says. And then when we talk about descriptive statistics, we're looking at the measures of central tendency. So that's your mean, median, and mode. You'll be taught that. Then we look at the measures of dispersion. So we cannot make complete sense of the data using only the measures of central tendency. The measures of central tendency, just as the name implies, gives us information about the center of the data, but it doesn't give us the degree of spread of how that data is, So we must report a measure of central tendency with a measure of spread or a measure of variability. So the measure of central tendency, measure of variability also is in the realm of descriptive statistics. Then how are we going to present this data? Using tables, using charts, using graphs, and all that for both categorical variables and numerical variables. So that is in the realm of descriptive statistics. Then sometimes you can have measures of position, centiles, deciles, quartiles. That is the values, in a data set, how it relates to other values. What's the position of a value relative to others? That's the measures of position. So all these, measures are under the realm of descriptive statistics. So for example, you have 500 postgraduate students. I've collected data, age, sex, and all the common things we collect as information. So I haven't collected that. I'm saying, okay, so what proportion are males, what proportion are females? What is the mean age and standard deviation of the study participants? What is the religion? What is the income? Marital status, all that, proportions and all that. Okay, this data set, 70% are married, 60% are females. We're just describing. We're not making any kind of conclusions. We're just summarizing what we see. And then we present marital status in a bar chart or something. So that's measure of data presentation. So all this is in the realm of descriptive statistics. Then in inferential statistics, some measures that are used to draw conclusions. Remember, we want to draw conclusions, and if we want to draw conclusions on the population using sample-based data, we can't use the descriptive methods alone. We need another type of another type of statistical methods to be able to answer the research questions that are tailored towards the use of inferential statistics. For example, I want to determine if there's an association between two variables. I want to determine if there's a correlation between two variables. So my mean and standard deviation will not be able to tell me that. You get. So one of the ways in which we can answer this, is to apply the inferential statistical methods. And one of such is either the use of confidence intervals. So confidence interval just tell us that, okay, we are 95% certain that the true population parameter will lie here. If we have a research question that we want to estimate where the true population parameter will lie, of course, I hope you know the terms I'm using. I'm saying population parameter. I hope we understand that. If it's sample statistics, I hope you understand that. So what would the population parameter lie? 95% confidence interval of the mean. Okay. For example, we calculate and we get 2 and 6. Okay, we're 95% certain that the true population value will lie within 2 and 6, something like that. Then the test of significance, which is the one that is common, that's the hypothesis test. So we want to apply a hypothesis test to test the hypothesis of no difference or no association, no relationship. So that is the test of significance. That's the one that is pretty common, where we talk about the t-test, the chi-square, the person's correlation coefficient, analysis of variance, all the various statistical measures, chi-square and all that, as statistical measures. Of course, at this level, at master's level, you cannot come with a study that there will not be at least one objective that you use an inferential statistical methods. You can't make all your objectives descriptive at this level. So at least there'll be one objective that you must at least need to have done applied an inferential statistical method at master's level. You can't make all your objectives for your research descriptive. Okay. So for deductive and inductive reasoning, still the same thing I'm talking about. Like, we're interested in finding out, making conclusions on the population from the sample. So we're more tilting towards inductive reasoning compared to deductive reasoning, because we're trying to make conclusions on the population from sample-based data. Okay, let's move on. So what's the role of statistics in health? In health or in public health? It can help in the diagnosis of patients' ailments and in community health. Not like diagnosis as in statistics will tell you what the patient has. No. It will tell you, it will help you in identifying the common issues that occur in the community or in that area. It will tell you that. Then, in the likely outcome of a disease or intervention program in a community. So by the time you do your summary measures, you want to see, by the time you do your EPID studies, like EPID and statistics, they really go hand in hand. So if you do a randomized control trial, for example, you want to know whether there are differences in proportions, differences in mean, whether the intervention group has more better prognostic outcome compared to the control group and all that. So you can't say that just by taking a difference. You must at least apply your hypothesis test to know whether that difference is a significant difference. That is, whether it is a meaningful difference or whether what it is that you are seeing, the differences that you are seeing in both groups, is as a result of chance, right? So the statistics is quite important. Selection of appropriate intervention for a patient or community. So if there are multiple interventions, by quickly doing some statistical approaches, you can quickly see what interventions are effective for the management of a particular condition. Then for health planning purposes, of course, particularly in community settings, you want to plan for the common conditions that occur in that community or in that area. And then for the planning and conduct of research, of course, part of this, the things we're teaching you so that you can be able to plan your research better. Planning for data analysis is not when you have collected your data, you now remember what to know. The data analysis plan commences while you are, it should be part of the planning, the conceptualizing. Just as you're conceptualizing your topic, your objectives, the data analysis plan, you are already thinking of it. So most people will just write and forget things. When they've collected their data, they want to analyze. They will now realize that some things are actually missing. They didn't collect some data, or one thing or the other happens and it's not supposed to be so. And then they will now come and start meeting statisticians to help them with their data. So meanwhile, it's more like medicine after death. So once you are writing your proposal, it's best for someone who has some knowledge on data analysis or someone who is knowledgeable on these things to at least put an eye on it before it is approved. So the person guides you on how to measure the variables appropriately so that you don't have issues during the analysis. Let's look at types of data. So we have the primary data, secondary data. So primary data, you obtain it through when you carry out your surveys, you go and interview people, whether it's self-administered, interviewer administered, that is all primary data sources. Then secondary data sources is that data that is readily available from hospital records, clinic registers, cancer registries, bibliographies, published works, textbooks. So these are the data that is readily available. So you can extract the data from these sources and perform secondary analysis on the data. So there's data, secondary data sources. There are also routine sources of data. For example, census. Census, in Nigeria here, census is supposed to be done periodically, about every 10 years. Every 10 years. So the last census was held in 2006. So we're long overdue for another census since 2016. I know we're supposed to have one year before last. It was moved. We're supposed to have another one last year. It was moved to this year. They said November, but we don't know whether that will still hold. So that's that. But it's a routine source of data that we get every 10 years. And if it's done properly, it has huge benefits and implications. Then when we talk about the vital registration systems, remember, these are routine sources of data. So the vital registration systems are registration of births, deaths, marriages, divorces. These are vital registration systems. For example, birth, everybody should have a birth certificate. Your children should have birth certificates, and it's one of the things that is commonly required for most of the applications that you would do, whether it's admission, whether it's, and sometimes even visa safe, you may need your birth certificate. So these are routine sources of data. And then, of course, where it is properly done and the registration is complete and correct, it's a huge information sources that we can get that can aid in planning, because it can give us an idea of the population for each birth cohort, as the case may be. So that is what the vital registration system. Okay. So same thing with deaths, death certificates and all that. So we have the registration so we can know what are the common causes of death in the locality or in the community, the common sources of death. Then what we can now attribute what proportion of the total causes of death as a result of a particular disease. All these have policy and practice implications. Marriages, the same thing too. Marriages is more or less like you're looking at the social component of the families, because everything is important information in public health really. So we need all that. Then, of course, if in a particular year we see a lot of marriages, happening and all that, of course, that may have implications for population growth. Same thing with divorces too. That may also have implications too, in its own way. So these are vital registration systems. Then institutions and health services can get routine data from these sources as well. Clinic registers, school health records, hospitals, health centers, veterinary clinics. In public health, these veterinary clinics are pretty important too because of emerging and re-emerging diseases. So immunization records of animals and all that, very important. Then disease surveillance and notification. we know that we have the DSNOs in the 23 in local governments around the country. So it's pretty important. Their notification records, so we can know what is notified, what has been notified, was there truly an outbreak, and all that. So all these things are pretty important. If we know that there are certain periods whereby there is usually notification of certain diseases, we can be able to plan better and anticipate before an outbreak actually occurs. So other sources of data that may not be routine, surveys, when we carry out our research works, for those in environmental, maybe you want to carry out surveys on certain areas. You want to measure environmental samples or pollutants and stuff like that. That's important. So these are all sources of data, as well as clinical trials, prophylactic trials. Data from these studies can also be used in one way. They may have policy implications, they have practice implications, and they can contribute to knowledge. Okay, so basically the same thing I was saying, interviews, questionnaires. In more advanced countries itself, they can send their questionnaires via mails, that is postal system. Just as we have NIPOST, they can send it there, or they can send it electronically. So for design, I expect that by the time you're doing your project, you should be using electronic data collection tools. Everybody's moving away from paper. Paper just wastes money and wastes time. So we can use electronic methods. So you can send it to email, send it as a link, or if you're using interview as research assistants, they have this in their smartphones, and they just collect the data, so you can see it at the back end. Also, primary data sources, depending on some kind of studies too, observations, where you have your observation checklist, and observe the participants and all that. So that is just a recap of what we have been saying. I've been hearing the word data and all that. That's just the plural form. But if it's a single number, we say datum, right? So the raw material of statistics is data. That is the raw material of statistics, which is, we can say numbers. So these numbers can be gotten from measurement, or it can be from counting. So you count things or you measure something. So when we go to the types of variables, I will explain better. For example, a nurse weighs a patient or takes a patient's temperature or counts the number of patients in the ward. A measurement consisting of a number such as 70 kilograms, 35 degrees centigrade, or 20 patients is obtained. Now, each of these three numbers is a datum, and when they're taken together is data. So that's just what it is. But let's look at the components of a datum. We have the unit of analysis, we have the variable, and we have the values. So what is the unit of analysis? The unit of analysis is the subject of interest. For example, you want to measure the weight of the postgraduate students. So the postgraduate students will be the unit of analysis. And it's important to note that the unit of analysis must not always be living participants. For example, I'm interested in the glucose levels in serum samples. That is, I take blood samples from, say, 10 people. So in this case, the unit of analysis will be the serum samples taken from these patients, from these 10 individuals, not necessarily the individuals themselves. And then the variable, it's the characteristic of interest. So that thing in the unit of analysis that is of interest that you can measure, that is the variable. So for the two examples I've given, the weight will be the variable, or the sugar levels will be the variable. While the values, of course, the numbers themselves, 50 kilogram or 7 millimole per liter, that is the value. Okay? So that is the value. So types of variables. So this is as basic as it can be for the statistics. By the time we now jump into very more advanced kind of, like when we're going to the hypothesis test and all that, you know, when we come into contact with these terms, it should not be surprising. So variables can be classified as qualitative or quantitative. So for the qualitative variables, we also call them categorical variables. That's the qualitative variables. They're also called categorical variables because we place them in distinct categories. Distinct categories. And one person cannot belong to more than one category. So they are mutually exhaustive. So once we have variables that we can put into categories like this, we call them qualitative or categorical variables. Then once we have numbers, you know, we can say that those variables are quantitative variables. So quantitative variables, we can have them into two distinct categories. For example, male, female, then surgical status, alive or dead. So even if you are gasping, we are going to place you in one category. Are you alive or are you dead? You are most certainly alive if you are gasping. Even if you're so, that's, I'm just trying to use that as an example. Or you can have them in more than two categories. For example, blood group. You know, in life, so far as the knowledge that is made available to us, we know that we have each individual has a blood group, and it's either one of four. Either you have blood group A, blood group B, blood group AB, and blood group O. So you cannot have blood group A and then blood group O at the same time. So this is an example of another categorical variable, but with more than two categories. So this is just an example. Then some categories too, we can place them in some form of order or ranking. By the time we get to the scale of measurement, you know, we will explain better. But it may sound so basic, but these principles are very important in our data analysis and in the choice of the hypothesis test that we are going to use. You may be so proficient in the use of all these statistical tools and softwares, but if you don't understand the principles, the choice of understanding how to use a particular, or when to use a particular statistical test, you know, just as we have with any computer device, is garbage in, garbage out. So if you're supposed to have used a t-test and you use a chi-square test, a value will come out from that statistical software. If you are lucky, it will tell you error. If it's something you pressed and you don't know what you pressed, a result will come out, but that may not be the correct result because you have used an inappropriate statistical test. So that's why most of this, we're taking the time to teach like this, and we'll try as much as possible to break it down so that you can easily understand, right? So one thing is to be proficient in the use of the softwares. Another thing is to understand the principles behind behind statistics so that you can give good interpretation to your results. Good interpretation to your results. It's not so much about, oh, it's significant, it's significant. What does that mean? What does that mean? And statistical significance doesn't equate to clinical significance and vice versa. So it's important to also state that. But the essence is it's so that we can know how to interpret our data correctly. And so somebody's asking about R and all that, understand the principles first. Once we understand the principles first, if time allows, we can do some demonstrations on at least some of the basic ones, SPSS, look at it and all that. But there are so many softwares out there, you know. So the truth is you should try to be proficient in one. Try to be proficient in at least one. There's SPSS, there's R, there's EpiInfo, there's Data, there's Jamovi, there's so many. You know, same thing too with data collection tools. There's ODK, there's Kobo Collect, SurveyMonkey, Google Forms. So just be proficient in at least one. Please use that one whole body first. Then you can build on it and start learning more and more. There's Python too, you know. So these are programming tools, analytical softwares that, you know, is out there. And more and more are still being developed because now, you know, everybody's talking about big data analysis now, big data analysis. So also Google is your friend, YouTube is your friend. You can begin to learn just by, you know, you can begin to learn, you know, small, just download some of these tools and just online, you can get dummy data. You can begin to practice small. And I would advise the only way you can be proficient is by doing. So in as much as you may give your data out to a statistician to analyze for you, it's an opportunity for you to use that your own data to begin to press, you know, 1 and 2, so that you may not be able to, like, maybe perhaps all the inferential statistics and all know everything and how the results come out. But at least, even if it's the descriptive statistics, learn in the software. So that if using your own data, you get a mean age of 40 years, and then what they are bringing for you is a mean age of 24. You can say, my own small knowledge, I got 40. How come you are giving me a mean age of 24? Something like that. So that's just food for thought. But if time allows, we can look at some of the basic softwares, you know, and look at it together. So the types of variables we have, I've talked about so I've talked about some things. So, okay, so let's look at the quantitative variables. I said numerical variables. So quantitative variables, they are numerical and can be ordered or ranked. So these are numbers. We work with numbers. So for the quantitative variables, they can be further classified into two groups. We have the discrete variables and the continuous variables. We have the discrete variables and the continuous variables. So these discrete variables are variables that are usually counted. So for example, number of beds in the world. You cannot have 23.5 beds. Is it that 22 or 23 or 24? You can't have a bed with a fraction, right? So that's a discrete variable. So far as you cannot, they do not have fractions, those kind of variables, but they are numerical in nature. That is a discrete variable. Same thing with number of children. So you can just say the following are discrete variables, except, so just look at whether that variable you will have a fraction. If you will not have a fraction and the outcome is numbers, is a discrete variable. Something you can count to, that's a discrete variable. Any numerical variable that usually will contain fractions, And then most oftentimes they are gotten by measuring. That is a continuous variable. So we have quantitative variables that can be subclassified into discrete variables or continuous variables. So we're in the realm of numbers, unlike the categorical variables or the qualitative variables that we're in the realm of categories. So for example, weight, depending on the sensitivity of the measuring instrument, you can have a weight of 65.2 kilograms. You can have a weight of 65.65 kilograms. If we have a very, very sensitive tool and measuring instrument, you can have a weight of 70.291506 kg, you know. So my point is, first you can take fractions, you know, and the outcome is numerical. Usually something that you measure, that is a continuous variable. So let's look at the scales of measurement. So the scales of measurement, variables can be classified in addition to either whether it's qualitative or quantitative, but they can be classified by how they are categorized, counted, or measured. For example, can the data be organized into specific categories? Can the data be ranked? You know, so there's many questions that we ask ourselves. But there are four major scales of measurement in statistics. They are either the nominal scale, the ordinal scale, the interval scale, and the ratio scale. The code is NOIR. NOIR, Abi, NOIR. So nominal scale, ordinal scale, interval scale, and the ratio scale. Now, the nominal and the ordinal scale are categorical, while the interval and the ratio scale, they are numerical. And it's important to note these scales of measurement because they are very important when we're looking at statistics and data analysis. Because even if you have a categorical variable, you want to ask yourself, is it measured on the nominal scale or on the ordinal scale? That alone can also inform the type of analysis that will be done. So let's dive deeper into the various scales. So this is an important concept in statistics. For the nominal scale, remember I said the nominal and the ordinal are categorical variables. But what differentiates the nominal scale and the ordinal scale is, number one, the nominal scale, these categories are mutually exclusive. So there is no order or ranking to these categories. In addition to the fact that they are mutually exclusive categories, there is no order or ranking to the data. There's no order, there's no ranking. For example, gender, you have male and female. We are not saying that females are better than males or males are higher than females in this context, but everybody will be placed in one category or the other. Same thing with religion. We have Christianity, we have Islam, we have traditional religion and all that. We're not saying that there's anyone that is better, there's anyone that is better than that. You know, so just 1 minute, please. This is a very important call. Sorry. Apologies, please. Sincere apologies. So sorry. A lot of things are happening at the same time, so I'm coordinating a couple of things. Sorry about that. Okay, so nominal scale. I've talked about nominal scale. Then for the what was I trying to say now? The categories. So there's no order to the categories. There's no order to the categories. So religion, you cannot say that Christians are better than Islam, or Islam is higher than traditional religion or Christian or all that. So there's no order, no ranking to this. Political party, the same thing. We're not saying that APC is better than PDP or PDP is better than AC or this one is higher than, no. We're just placing them in mutually exclusive categories. So even if numbers may be given to these categories, those numbers do not mean anything. It doesn't have no numerical strength, no numerical meaning. So even if we say males 1, 2, females, we're giving numbers to those categories. Does not mean that females are 2 times better than males or 2 times higher than males or 2 times at risk. No, that's not what we mean. We're just giving numbers to those categories, perhaps for ease of analysis. But those numbers given to categories do not have numerical strength or meaning. So that's the nominal scale. So when you see a categorical variable, you ask yourself, where is it measured in? Is it the nominal scale? Is it the ordinal? Is it the ordinal scale? So let's look at this ordinal scale. So the ordinal scale, same thing, categories. But these categories can be ordered or ranked. For example, level of education. We know that it's either you do not have any form of education, you have primary education, you have secondary education, you have tertiary. We know that one comes before the other. So there's some form of order, there's a form of ranking. We know that someone who has tertiary level of education is higher than somebody who has primary level of education in that context. What it doesn't tell us is to what degree does one level or one category differ from the other. We cannot get that. We cannot get that. So same thing with social class, low socioeconomic status, moderate, high, and all that. Levels of disease, the same thing, right? So precise measurement of the differences in these categories does not exist. So the nominal and ordinal are under the categorical variables compared to the interval and the ratio scale. So the interval and the ratio scale are in the realm of the numerical variables. So with that, we know that one number is higher than the other number by a certain amount, right? So precise differences exist between the units. So the units now are the numbers or whatever it is that is counted or measured. So we know that an IQ of 109 and an IQ of 110, there's a meaningful difference of 1 point, 1 IQ point between an IQ of 110 and an IQ of 109. Same thing with temperature. We know that there's a difference of 1 degree Fahrenheit or 1 degree centigrade, between 72 and 73 degrees Fahrenheit. So one of the key things about the interval scale is that it does not have a true zero. When we say it does not have a true zero, meaning that 0 is just another point on the scale. For example, temperature in Fahrenheit, once you see 0 degrees Fahrenheit, it does not mean the absence of heat. It's just another point on the measuring scale. You have 2 degree Fahrenheit, you have 1 degree Fahrenheit, you have 0 degree Fahrenheit, you have -1 degree Fahrenheit, just like that. So 0 does not mean the absence of heat. Same thing with location as per longitude, latitude. You have longitude 0 degrees. I think London is on longitude 0 degrees. Doesn't mean that that place does not exist on the surface of the planet. It is just another point on the measuring scale. So that's the key difference between the interval scale and the ratio scale. In as much as we know that the interval and the ratio scale, they are both numerical variables, but they are both numerical variables. But for the interval scale, there's no true zero. However, for the ratio scale, there is a true 0 point. So the ratio scale has all the characteristics of the interval scale, and there exists a true 0 point. So when we say a true 0 point, that means 0 is 0, nothing is there, right? And then the ratio scale contains a true ratio between values. So if a person can lift 200 pounds and another person can lift 100 pounds, then the ratio between them is 2:1. So there's a true ratio between these components. So that's why we call it ratio scale, things like that. But the key thing there is that there's a true 0 point. There's a true 0 point. Okay? And then the interval and the ratio scale can be categorized. And this is important in our data analysis plan. So anything that you're measuring, even if it's in numbers, you tell us whether you're using the numbers as they are or you want to categorize. For example, if you say weight, weight is measured as numbers on the ratio scale. So we say weight, you say 70 kg, 60 kg, 65 kg. So we have the weights of everybody. But if you do not want to use those numbers like that, you want to categorize it, right? You can categorize them as maybe all those less than 60 kg, low weight, 60 to 70 kg, normal weight, those greater than 70 kg and above, they are overweight, for example. You have now categorized that ratio scale variable into a categorical variable. Even as it has gotten to a categorical variable, you will still ask yourself, is it measured on the nominal scale or on the ordinal scale? Because we have done low, we have done normal, we have done high. So there's some form of order, there's some form of ranking. So that is now measured on the ordinal scale. And it's important, particularly in your data analysis plan, you tell us if you are measuring something as numbers, you tell us whether you want to use those numbers as they are, or you want to categorize them, such that it is now a categorical outcome. Because this will now influence the type of statistical test you will use to answer that objective if it requires an inferential statistical analysis to be done for that objective. So it's important to state that. So these are some revision exercises that we can do. Perhaps we'll talk about them tomorrow. So you can go back, look at the slides, or share with the course rep, and then we can start with this tomorrow, and then I'll know your thoughts on this. So any questions so far? For the course rep and co that is coordinating the hosts, okay, I've been made a host. So if you have a question, please just raise your digital hand so that yes, we can start. Agama. So course rep, I think you are part of the hosts. Just be unmuting them as okay, I am even part of the hosts. So let's start. Yes, I have this David Agama success.
Yes,
you have
sir.
the floor, sir.
Good evening, sir. So my question is just a little, I want to get the example of ordinal scale. Like, can you give me an example of ordinal scale?
Level of education.
Okay. Level of education.
Level of education. So level of education, it's in categories. Don't forget I said the nominal and the ordinal, they are categorical variables, right? So for the nominal, there's no ranking to them, but for the ordinal to them. So level of education, no education, primary, you can see that there are levels to it. If there are two people standing and one has tertiary level of education, the other one has primary level of education. Already in your head, you know that this person is more educated than this person. So,
Okay.
so far as you have the categories, you can have some form of order to them. That's one comes before the other, or some form of ranking. This is first, this is second, this is third, to the categories. Then that variable is measured on the ordinal scale. So using that, give me an example of a variable, another variable that can be measured on the ordinal scale. Success.
Okay. Let me see. I'm trying to process what I'm going to use.
Look at this. Look at the slide on your screen. Look at F. Are you seeing F? What this thing is that? What scale of measurement is that? Are you seeing this? Are you seeing this slide? Success. Oh, she can't. Please, let me see. Let me unmute her.
Hello,
Yes,
sir. Can
success.
you hear me?
Yes.
Sorry, I was muted. So
Yeah.
I can see the F. It says ratings of 8 local plays: poor, fair, good, and excellent. Okay. So this is an example of the ordinal now, because you'll be able to know, for example, now if you want to grade the students, once you see excellent, you know the student performs well. Once you see poor, you know the student doesn't perform well. So is that what you're trying to explain, sir?
Okay. Yes, that's measured on the ordinal scale.
Okay,
So I think
sir.
you get the hang of it.
Okay, thank you, sir.
Okay. So Uwem
Hi.
Ima.
Yes, I can hear you. So my question is, since this is the first day we're starting this class, there are certain things that I'd like to know just so I can prep myself. So it's not necessarily directly tied to the course. So based on the experience I've had so far, in the two classes we've taken, I want to clarify what the class structure for this class would be when it comes to testing, when it comes to tools we'll be using to analyze data, since this is a biostatistics class. And then would there be review? Would you provide us with a clear scoring system for when we do take a test? Um, so these are things I would like to know. And the class materials, would all of these things be given ahead of time so we can prepare and have all our materials ready? Um, and then in terms of questions during the test on exam, how many of them would they be? Sort of tell us more about your structure and how things are. That way, all of the issues that we've faced so far in previous classes can be prevented.
Okay, so it will be shared with you. Sorry about that. You'll get the schedule today. You'll get the schedule today. I will liaise with, I'm not the only one teaching this course. So I will liaise with my other senior colleagues. And then we would decide on how to assess, because with every year, we're trying to tweak something or the other so that it can be better and better, because it's quite a large class. So it will be better and better. For the tools, depending on the, based on the time available, we'll try to squeeze in a practical session as much as time can allow. This is time-bound module system. So as much as time will allow, we will try to squeeze in something. SPSS is a common one, but we can throw in, again, the limitations to this is for data analysis practicals, you get the time we have is not enough. But we can show you some things with some of the common ones like SPSS, R, Stata, and all that. Try to see how we can squeeze that in. Yes, it's a biostatistics class, but most importantly is to understand the principles. Anybody, please, you need to go and learn as much. What we teach you is just basics, really. But we will try to see how we can factor in. So that's why, for me, I'm not really going to so focus on all the calculations and all that, because right now, nobody's going to be in real life situations. Nobody's going to be asking you to calculate anything by hand, right? It is the interpretation of these things that is most important. So a typical exam question can be an output from a data analysis software that you should interpret. So if I have my way, that is the kind of things I would set. But like I said, we'll liaise with the school so that we know how to best improve your knowledge on statistics with the limited time that we have available for the course. For the materials and all that, usually I try to send mine ahead of time. Again, today it was just some unforeseen circumstances. So you get the schedule. I just wanted to clear from the school. You get the schedule, you will get the slides, you will get everything that you need. Yeah, for that. I hope I've been able to answer that question. Yeah, so who asked the question?
Yeah, you've answered some of them. My last one is around emails. I've sent all the professors email. None of them has responded to me, which is quite odd. And I'd like to know if you have an email, someone like email we can send questions. Because even when we take tests, there are some questions that are phrased incorrectly, all of those things. And there are things I want to clarify, and there's no one to talk to. So if you could provide an email or something that someone can have to like reach out to you, I recognize everyone is busy and there's a lot of students in the class, but being able to, giving that this is a graduate level course, this is not an undergraduate course, I feel like there should be a level of professionalism amongst students and the professors to collaborate and effectively learn. And that's not something I've noticed. Again, maybe this is unique to Nigeria, but it's not something that's common where I am. And I just want to get something, someone I can ask a question, clarify, and all that. So yeah.
Okay, that's okay. You can reach me. I'll drop my contact details, but anything that will require the school to do a response, maybe I'll just follow up on your behalf. Okay, so any other questions? Yes, there's some other hands up, so let's see. Marilyn, you have the floor, Marilyn.
Okay, good evening, sir. I want to know if you talked about method of data presentation, because that's where I want to ask my question.
So we haven't gotten to that. Is in the schedule. It will be taught.
Is that right, sir? Thank you.
Okay. Christopher Essien.
Yes, good afternoon. Good evening, Doctor. Thank you for the presentation. Please, I want to mix the difference between the ratio and the interval scale. So please, can you throw more light on that? And then the second question is, since our lectures today is time down, I want to ask or appeal, is there any way we can arrange or maybe a special day for us to be able to look at the examples on that analysis subject, because it's very, very important to some of us who have not really had experience with that. Thank you, sir.
Okay, I'll start with your second question. I think I've said something about it when UM was asked this question. So I think that's the same. Then for your other question, I think it's you said interval and ratio scale, right?
Yes.
Yes. So for the interval and the ratio scale, they are quantitative under the quantitative variables, or they are quantitative variables. It's just that we need to now tell which of the scale of measurements is measured in, whether it's the interval scale and the ratios or the ratio scale. So one of the things that you can use to distinguish them is to ask whether it has a true 0 point or not. Most of the variables in nature are measured on the ratio scale, right? So most of the common quantitative variables that we encounter in science, in health, in biology, are all measured on the ratio scale. But what we should ask ourselves is, okay, does the presence of, if there's 0 as part of that variable, as part of the value of that variable, does it mean the absence of that entity? If the answer is no, it doesn't mean the absence of that entity, then it's measured on the interval scale. But if the answer is yes, it's measured on the ratio scale. But just know that the ratio scale also has all the properties of the interval scale, except the fact that it has a true 0 point. That's why sometimes some of these data and analytical softwares would take the interval and the ratio scale as numerical or scale variables, because there's really little to distinguish between the two, except maybe this 0, absolute 0, right? But generally, that's just the minute difference that occurs between the interval scale and the ratio scale. Particularly the interval scale, 0 does not necessarily mean the absence of that entity, as I had earlier explained. So we can go back and read through, find out more and understand it better. Christopher, I hope that's okay. Yes.
Yes, thank you very much.
Okay, we have Esther Sampson. Esther Sampson, you have the floor.
Good evening, sir.
Yeah, good evening.
Okay, my question is similar to the last question that they asked now. I really want to know, can you give an example of variables having a true 0 and then the ones having no true 0? So I didn't understand it. Can you give an example?
So I gave an example of temperature. So in temperature measured on the Celsius or Fahrenheit scale, right? For those in temperate regions, you have 0 degrees Celsius or 0 degrees Fahrenheit, right? But the fact that temperature is measured as 0 Fahrenheit or 0 Celsius does not necessarily mean the absence of heat. It is just another point on the scale. Same thing with longitude, that's location, longitude, latitude. For example, we know that I think it's London is on longitude 0 degrees. It does not mean London is not located on the planet Earth. I don't know if you understand.
Okay.
So for the fact that it's on, like Nigeria is on longitude 15 degrees, at least 4 to 15 degrees or thereabouts. Generally, we say +1, right?
Yeah.
Yeah, so about 15 degrees east. So for locations that are on longitude 0 degrees or latitude 0 degrees, it does not mean that 0 means that that place cannot be located on Earth.
Okay.
So it means that 0 on the temperature scale or 0 on maybe longitude or latitude in terms of location, right? It does not mean the absence of heat or the absence of location. So that's those kind of variables. That's why you find they are numerical. They're measured on the interval scale.
Okay. All right. Thank you very much.
Good evening, sir.
Yes, good evening.
Okay, sir. Thank you very much for your lecture, sir. So please, I didn't quite get what you said about parameter and estimates. If you could throw more light on it, please.
Okay, so I was trying to say that in practical settings, it may be difficult to work or carry out a study in the entire population of interest. So most times we work with samples, right, for various reasons. Be it cost, be it logistics, or even ethical reasons, right? So we want to ensure that the sample is a representative of the population from which it was drawn. But in situations where the variable of interest in the population we're able to measure, right, that is the population parameter. But the truth is, most times, we may not know what the population parameter will be. And I use the example of maybe the entire postgraduate students of university or something. We may not be able to know what that population parameter will be. And what is this population parameter? It can be the weight, the mean weight, can be the mean height, can be anything, can be any variable. Can even be a proportion of something. Proportion of postgraduate students with HIV and AIDS, for example, can be anything. So that's the variable. But most times, because of the large number in the population, we may not be able to get that. If we were able to get that, the summary measure we estimate, we calculate from that population is the population parameter. But most times, we may not know what the population parameter is. So we work with the samples, and then whatever we estimate from the sample, that's a sample estimate, right? We're now using that to make inferences on the population value, that's the population parameter. So if we were to take a sample of 500 individuals from a population of say 10,000, and we have a mean weight of 60 kilograms. So the question is, how does this, if we were able to study the entire population, let's say of 10,000 individuals, will the mean weight be equal to 60 kilograms as well or not? But in this case, most times, like I said, in real life situations, we may not even know what the population parameter may be. And that's why this inferential statistical methods are important. So we can say, okay, we have 60 kilograms as our mean sample weight, but we plus or minus maybe our standard error. We are now saying that, oh, it's likely, or maybe our 95% confidence interval, oh, it's likely that the true population mean weight will lie within this and this, right? So in inferential statistics, by the time we start all that, the principles behind all that, we will now understand how everything goes. So that's just the difference between the population parameter and the sample estimates. I don't know if you are clear. Okay, I can't hear again. Who asked the question now? I hope you are clear. Okay, so Luke Evans, you have the floor, sir.
All right. Good evening, sir. Thank you for your presentation. So I want to understand this nominal scale thing you talk about gender. We do know, although we don't have it here in our environment, but overseas, there is this pronoun. They call themselves they or them. So where will you place them? Where will you place those category of persons under gender? Thank you.
Okay, so it's still the same thing. It's still the same principle. Here in Nigeria, we recognize only two. So mutually exclusive categories, either one or the other. So if you are in settings where these other forms of gender identity is recognized, right? Still the same thing. You put the different categories there. Male, female, them, I don't know what the other ones are named. So if you're in those settings and you are collecting data in those settings, so you put all of them. So that's all nominal variable, right? Still a nominal variable, but it's just that here in Nigeria, we recognize only two, male, female. So if you're in settings that recognize more, it, them, whatever, right? So in those settings, so when you have to be sensitive to those things, if you're in those settings and you're collecting data in those settings, so you put the appropriate categories as as is culturally accepted. So that doesn't change it from being a nominal variable. It is still a nominal variable. Just that you have now allowed other categories because that is what is culturally accepted in those regions. So it doesn't change the fact that it's still a nominal variable. I hope that's clear. Okay, so last but not the least, Augustina Agbudume. You have the floor, madam. Augustina, you have the floor. Can you hear me? Okay. Augustina, you have the floor. You can okay. You can ask your question. If none, okay. So Augustina is not saying anything. So at this juncture, I think we can call it a day. So course rep, I will forward everything that needs to be forwarded to you so that you can pass on to the class members. See you tomorrow. Good night, everybody.